I always love listening to that music in the background just before the show starts, and I'm just like waving and kind of dancing to the back. Hey everybody, welcome to another Stripe Dev Chats. My name is Cecil Phillip, and today we're going to talk about an interesting topic, which I'm sure a lot of y'all might be wondering about. We've been hearing a lot about it on the internet, and that's verifiable credentials. Now, for us as Stripe, usually we talk about all of the different ways that we can try and secure and protect our applications, right? We think about like fraud protection. We think about people stealing credit cards, and we think about impersonation and all of these different types of things. And I'm sure you do as well, as you're trying to build your applications also. So when I heard about this standard, verifiable credentials, I was like, oh, okay, this sounds pretty cool. And so why don't I get some folks that actually know about it, which obviously is not me, to come on here and talk about it. So we have two folks here from Auth0, Damian and Jose, that are going to tell us a little bit about it, show us how it works, and be able to answer some of our questions as well. So, gentlemen, why don't we start off with just a quick round of introductions? Damian, let's start off with you. Why don't you tell folks a little bit about who you are and what do you do?
Thanks, Isil, and it's great to be here. So my name is Damian. I'm an engineer working on Auth0, the product. Auth0 is a product that does identity as a service for developers, meaning that if you're a dev and you need to implement the login box, we are a good way to go. Back in the day when we were starting Auth0, we used to say we are like Stripe, but for identity. And Auth0 recently got acquired by Okta, so I work at Okta, the company. And in particular, I lead a team within Okta called Auth0 Lab. And what that team does is it researches the future of identity and adjacent areas to figure out what we should be building. And our focus for the past 13, 14 months has been figuring out verifiable credentials, what we should be doing with them, and where the industry might go as that becomes a hotter topic year over year.
So you're the guy that gets to play with all the cool stuff, because like I'd love to work on a research team where I really just get to try out and play around with a lot of new technology every day. Is that kind of similar to what you
do? That's a very fair assessment. I always say that me and folks on the team have one of the best jobs in SaaS.
Awesome. That's beautiful, man. So Jose, why don't you go next? Tell us a little bit about yourself.
Okay, hello everyone. My name is Jose. I work in the same team that Damian. Yeah, we have been digging in this new specification for a long time and testing and working with this. So this is a particularly interesting topic right now, because decentralization is a hot thing. So we are, we have been working in this for, I guess, a year or more. And one of the things to consider is that it's a fast-moving standard. So there are a lot of new hot things coming out. So yeah, basically that is a big lover of Stripe and Stripe APIs, which have served as an inspiration for a lot of things in Auth0. So very glad to be here.
Nice. So a couple of months ago, we had one of your teammates. His name is Will Johnson, and he was on the show talking about Auth0 actions, right? And I think one of the things that I took away from that is that like Auth0 does way more than I even know that it did, right? So when I think about Auth0 in general, I think about, okay, I need usernames and passwords. Like I need to log into an application, but I don't want to manage it. I want you to manage it instead, right? And so I kind of like offload that service to you, and I just worry about like plugging in like your UIs and your SDKs into my system. But at the end of the day, like you're managing that data, right? And us at Stripe now, we have a different type of product too. We have Stripe Identity, which is not a username password product, but that is an ID verification product. So you can give us passports and driver's license and those types of things. And we could say, okay, this is a valid form of identification or not. But then that still is not attached to like a user. Like no one signs in with that. That's just to say, hey, is this valid or not? So as you're talking about verifiable credentials, I kind of feel like, and let me know if I'm wrong, but I kind of feel like it's a little bit of both of those kind of put together. Would that be a fair assessment, Damian?
Yeah, I think it is. The thing with what you were mentioning, Stripe identity and what it handles is you have physical credentials from the real world, your driver license and your passport, and you can touch them, right? They are very much real. And what these flows around fraud prevention and what's known as know your customer or KYC attempt to do is they attempt to make sure that a particular user account, a digital account on a system, for example, might be for a bank or a loan app or whatever, belongs to a real person. So you're trying to kind of like bridge the real world and the digital world. And that's where that KYC, that Stripe identity comes in.
Yeah.
Auth0 deals with digital identities and verifiable credentials kind of like bridge these two worlds by thinking of your day-to-day physical credentials, like your driver's license, which again is a particular case, like your passport. You might even think about other things like your employee card or your university diploma or even a COVID vaccination card that says, hey, I really got vaccinated. All of those are really credentials, right? Someone, an entity is issuing it. They are vouching for the fact that something happened. For example, if you have a university diploma, it's that you really graduated from a particular university. And the fact that they are digital means that they should be easier to integrate and also for people to work with as you try to implement those into different systems.
Okay, that makes sense. So then, like you're saying, I can have like the COVID vaccination card as an example, right? Like someone's going to give me like this token or this artifact, right? And then now I can go to, I don't know, the airport or the pharmacy or whatever the case is with this COVID vaccination artifact. And then now they could be like, okay, well, this is valid or not, right? But they could do that in a reliable way because I'm going to assume that there's some middle person or some other party other than me and there's me, the pharmacy, and then someone else that's going to say, hey, this is a good thing for you to use. You know what I mean? Because again, today, if I think about a driver's license or passports or whatever the case is, like a lot of the times those things can be, you know, duplicated, photocopied. They could, you know, things can happen, right? And so now the question is, well, is this valid or not? Is this real or not? Is this photoshopped or not? You know what I mean? Like, can I trust that the person that's standing in front of me or signing into my application is actually the owner of the thing that they have? And so you're saying that's kind of the problem that verifiable credentials is trying to solve. Yeah.
Yes, definitely. And maybe it would be good to kind of like dive deep into kind of like a demo and a couple of examples so that folks can get more familiar with some of these things. So I'm going to share my screen, if that's okay.
Yeah, sure. Let's do it.
Let's see, window. Okay, this one. So as Jose was saying, verifiable credentials and digital identity and anything related to also what's sometimes referred to as decentralized identity, although some of that might be a bit misleading, it's moving very fast. There are lots of standards, lots of formats, everything's new. So when we say standards, verifiable credentials, for example, it's a W3C standard, and it has been approved. But a lot of the standards that typically are used to work with them, for example, what's the protocol to what's known as issue a credential, what's the protocol to verify a credential, those are moving and they are moving very fast. So one of the things we do at Auth0 is we try to make things simple for developers, and particularly in anything related to identity. And it's not just about a great product that has a fantastic dashboard UI and nice APIs. It's also about explaining concepts and documenting. So we came up with this idea of creating a site. We call it verifiable credentials.dev, where we try to walk people through what a credential is. So we make it first clear, hey, they're a standard for digital. So this is, again, in contrast to physical, cryptographically verifiable credentials. And what this means, and this goes exactly to your point, is this is about avoiding counterfeit. It's about making sure that no number was touched in the passport with someone's pencil, very skilled hand, and then that no one is making you believe that you have a passport from a country that never issued that passport. You're trying to prevent all of those things. You're trying to prevent tampering. And that's very powerful because when you take digital and when you can avoid fakes, you can go through a lot of the flows that you described around know your customer, around identity verification a lot quickly, right? Like there's no more, hey, take a picture of yourself, opening your mouth, holding your passport in a 45-degree gamble. You just, hey, submit this credential and it works. Now, what does that mean? Well, let's look at a few examples, right? And here we're going to mix a bit of code with kind of like the real world. So let's say we have an ID card. In this case, this could be an ID card for a country or a city, anything that the government uses to state that you are a resident or a person that lives there. The first thing that a credential has, and you can see that this is JSON, right, where you have a bunch of properties and their value. A big property here is what's known as the type. And typically the verifiable credential specs says, hey, one of them needs to be verifiable credential. But then you start getting into what kind of credential this is. So in this case, it's an ID card. If I had a university degree, it would say something like university degree. Now, as you can see, these are strings. So this is something that's still not standardized. But what we're trying to convey here is what type of credential does this JSON blob represent. Then another big thing is what's known as the issuer. And this is the party or the entity that's stating a fact about a subject or the person, right? So in this case, Hannah is a citizen of the Asgard country. And what we're saying here is that Asgard state is an issuer of this credential. And this is very important because as the issuer, they are the one that anyone that wants to verify a credential needs to trust. If you don't trust, for example, passports from a particular country, I'm going to use Argentina because that's where I live, but it doesn't mean that you shouldn't trust our passport.
Yeah.
Then if you, that means that anywhere where I present my passport, regardless of what the data in it says, if you just don't trust it because it comes from Argentina, it doesn't matter. So this is why the issuer is very important. And we're going to get into how that's relevant when we go into kind of like the cryptographic verification of these credentials. The next thing is the credential subject, and this is all of the data about the subject, typically a user, but there might be other kinds of subjects that a credential represents. And here you can see Hannah's name and date of birth and other properties. And finally, a proof. And this is the cryptographic proof, where essentially it's a signature with a particular algorithm, which is the one described in line 23, of all of the attributes included in that credential. What that means is that when you want to verify this credential, you essentially need to check that signature. So who signs the credential? The issuer signs the credential. And let's go into kind of like a flow of how this all works. And this is where we try to kind of like make this clear. The first thing that happens is that a subject gets a credential from an issuer, or the issuer issues a credential to a subject and then sends it over. The subject would store these credentials on an app, typically on a mobile device. Maybe it can also be kind of like a laptop computer or a home computer, but you need to have an app that can hold these credentials. And this is typically known as a digital wallet in the verifiable credentials ecosystem. Now, one thing that's very important is that the issuer, when they issue the credential, does not know how Hannah, in this case, and where Hannah is going to present it, right? And that's the same case as when you get a passport. When you get a passport from your state doesn't know where you're going to travel. And if you're going into a bar in a different country and you need to show your passport, your state doesn't need to know what bar you're going to go to beforehand. And this is different from typical identity protocols today, where you do need to say where you're going to present a token or a credential that you're trying to get.
Right.
The second thing is, finally, Hannah decides to present this credential to a verifier. And what the phone application does, what the wallet does, is it takes that credential presentation and it takes that credential and it wraps it into what's known as a verifiable presentation, which essentially adds some extra data to the verifiable credential around making sure that there's no repeat. So again, it uses not to make sure that there are no replay attacks, and it adds a few other properties that are specific to that interaction between the verifier and the subject. And optionally, the subject itself, in this case, Hannah and Hannah's device, can decide to sign the presentation using Hannah's private key. And this is interesting because whenever you get a presentation, you're not just getting kind of like a credential that might be issued from a particular issuer, in this case, Asgard State, but you're also getting a presentation that is signed by Hannah, and then you know that it was actually Hannah or someone using her phone that actually presented this. And finally, this is where the verification comes in. There is a verifiable data registry, and it might be a database, it might be a typical like HTTP URL, or in some cases, and this is where some of the decentralized identity story comes in, there might be a blockchain. You go fetch keys for both the user, in this case Hannah, and the issuer that you trust, and that's where you go verify the signature for these credentials. So essentially, an issuer gives the credential to a subject, the subject decides to present to the verifier, and then the verifier checks the verifiable data registry to get the keys to verify the signature for the presentation.
Okay, so that makes sense to me. And as you're talking about it, let me know if I'm thinking about this the wrong way, but this sounds a lot like OAuth to me in my head. Only from the perspective of, again, I have some SDS, right? Secure token service. I sign into the service, they give me some credential, you know, and then maybe let's say this is Google, right? I have a Google account, right? Google's my SDS. And so now I can go and I could say, hey, I want to sign into 3 or 4 different websites using Google. But now Google is just the central authority that owns that credential. But I just happen to be using OAuth, right? It's a similar model, but I'm guessing like there's some differences there, right?
Yes, definitely. So as you say, the model is similar, and as a matter of fact, the one of the ways in which you can both issue and present credentials for verification is using a protocol that's being developed called OpenID for verifiable credentials and OpenID for verifiable presentations. And OpenID is an extension to Auth. So again, those are very linked. So okay. One is about kind of like how you transport and like how you communicate between the devices. The other one is more about like the format. But the main difference between kind of like that federation use case where you're trying to do is kind of like signing with Google and this one is this thing that I mentioned earlier, which is there is no audience, and essentially the audience is the entity which is going to get your credential when you're getting a verifiable credential. Whereas when you're doing typical auth with Google, there is, because if you're logging into an application using Google, let's say, I don't know, I'm logging into Miro using Google, Google needs to know that I'm sending, like that the token that it's going to give back to me is going to Miro, and typically it's encoded in a JWT that says audience Miro API or something like that.
Right.
And that means a couple of things. That means that Google knows that I'm using Miro. Might be interesting, might not be interesting. Like Google can figure things out in other ways, but this is very clear. Right. But at the same time, every time I need to do something with another API, another server, sorry, it's the other way around. It's like Miro knows I'm using Google. Sorry, I mix those up. Like you want to talk to the Google API. But the interesting thing there is that every time that you want to do something else, right? Like let's say you have to call another service or another service wants to call Google, you have to go get another token. And what that means, and this is more kind of like from a distributed systems perspective, anytime you want to talk to a verifier to present your credential, the issuer might need to be up if you don't already have a token, which means that from an issuer perspective, right, in this case, Google, you always need to be up to be ready to hand out a new token. And that's expensive, right? Like the reliability model of this whole thing changes when you think about, well, actually the phone is more like a cache that's taking these cryptographic proofs and it's holding them and it's always available. So all that the phone needs is just to connect to the verifier without needing to come to the issuer. So there's a privacy aspect, but there's also a reliability aspect that's interesting here. And then you can also do interesting things where and this is again more advanced and requires kind of like advanced cryptography, you can use techniques known as zero knowledge proofs or selective disclosure with a new spec called SDJWT, which is still not tied to verifiable credentials, but it seems that that's coming, where if you have, let's say, 4 or 5 properties in your credential, like this one, right? Like where you have an identifier and a personal identifier and a name and date of birth, but all you're trying to do is really kind of like get into a bar. You just need to prove, let's say, that you're over 18. So maybe you just give out your date of birth. So, hey, you don't give out your current address, so Hannah doesn't get doxxed. Seems important. And you could do that if you were kind of like in an auth exchange, but you would have to go get different claims for the different verifiers, which is not ideal. Like again, it means that you want to get another token for each of these audiences. And then finally, you could also use what's known as, again, a predicate zero knowledge proofs to just prove that you are over 18 or over 21. And I say over 18 because that's the legal drinking age in Argentina. In the US, it's 21. But that means that you don't even disclose your date of birth. You just say, hey, I'm over 18. And that is not inherently related to the verifiable credential. Like you could be doing zero knowledge proofs with other formats, but this is a very big part of the spec. That this is something that a lot of folks spend a lot of time thinking about and are pushing, even though it's not it's not directly tied to a verifiable credential.
Okay. All right. So that makes sense to me. And then looking in the chat really quick, it looks like we have a friend here from YouTube, Martin. Martin says, we should mention that the owner owns the data in the VC architecture. I'm the traditional OAuth flow, for instance, Google. I'm guessing it means in the traditional OAuth flow, for instance, Google owns the user data. So then, like you said, I guess there's a difference in like the ownership. Like, who does this belong to?
So I think there's a value proposition of what some folks, and me included, would like to see happen in terms of like privacy and ownership versus reality. For example, let's say you are an issuer of a credential that's a university graduation degree credential, right? So it says, hey, Cecil graduated college. So you have it on your phone. What, I don't know, something happens, and let's say you had the best backup strategy. So you had 2 phones, you had a laptop, you had your private key also copied somewhere else, and I don't know, big explosion wipes out your whole town. Again, case, but again, things happen. You still graduated college. So there's a record in college that says Cecil graduated, because when you go buy another phone, you need to be able to get your diploma again.
Right,
so
that makes sense.
The college can't just go and delete all records that you graduated. You don't want that either. And maybe if you do want it, there's risk. So ownership of the data in your phone, yes, is yours, and you have the credentials and you decide where you present them. But there might be legal reasons why companies or entities keep transactions of what happened, right? And yeah, they could anonymize things with, again, hashing internally in their own systems to minimize PII, but that's on them. Like, you need to keep a record of who spent money on credit card transactions, right? Like, you can't just forget because it's presented with verifiable credential. You need to have a record for audit, for accounting, and so on. So I think there's, ideally, you would minimize the data that you keep. There's an incentives problem here, right? Google wants to keep your data. It's not that they need to keep your data. So ultimately, I think one of the things that could happen, and it's not, again, just necessarily because of verifiable credentials, but some of the things that verifiable credentials bring in terms of like being able to query exactly what attributes you want to share and so on, could make it so that when you go present a credential, it's clear in your app what attributes you're sharing, and you very clearly decide what you share with a verifier or not. The issuer has whatever they want, but ultimately it's going to be an incentives thing. Do you have the incentives to say no when a verifier asks for more data than they need? And the reality is that if you really want the service because it's free or whatever, it's going to be your choice. Much like it is today, right? No one forces you to use some of the services. So I think there are some improvements. Verifiable credentials also have a property called terms of use, which essentially would allow theoretically users to say how they want their data to be used.
Yeah.
But that also would need to be regulated and enforced. So until all of those things happen, it's not completely, I would say, accurate that you own your data. Maybe there's a better set of communication primitives that would potentially allow you to own more of your data.
Okay. So
a quick comment on selective disclosure, just to give you an idea. Like in the ID token or access token world, your application is requesting you access to some level of information. This is typically like the prompt you see on Google. This application wants access to your email or in your Facebook prompt. Where the similarity between the ID token and the verifiable credential ends up where an ID token has a short expiration usually, and you are constantly requesting that from the provider. Whereas the verifiable credential is issued once or maybe a few times, and it's something you hold. It doesn't have expiration and it doesn't have audience, as Damian said. So it will typically contain all the information about you or about the subject. And this is where selective disclosure is important, because you don't want to present everything every time you have to present, right? So this is like the different aspect between like the two words.
yeah, and you said one thing that I kind of want to touch on a little bit more. So you said, the credential from the issuer might be issued maybe once or maybe a handful of times, right? So I'm going to assume, let's say I'm using my Apple Wallet on my phone, or Google Wallet, or whatever your phone's wallet application is, right? But the credential is on my phone, right? And I lose my phone, or again, just like every other thing, right? I lose my credit card, I lose my phone, I lose my plane tickets. So is it a case of I could just go back to the issuer and get another one? And now, does that new credential have like a different lifetime? Like, does it have a renewed lifetime or renewed expiry date? Or maybe does it depend on the type of credential it is? Because I can imagine a university ID would have a different expiration versus a driver's license, as an example.
Yeah, so regarding expiration, this is handled by the spec. So you can attach an expiration as you will typically do with an ID token. Usually it's longer. It will be like 1 year, 4 year, or whatever, right? There is a problem in the backup thing. What you usually want to backup is all your wallet. But at the very least, you have to back up the private key, which is in the wallet. That's the most important thing, right?
Okay.
I can imagine, like, if I need to require a new diploma in my university, and I lose my private key, I will have like another method, maybe with know your customer, like your Stripe identity, right? Or something like that, where I can prove my identity and I can handle then my new public key in order to get a new certificate. There is also another part of the spec, which with regards to revocation, right? That's another important thing, because even if a credential might expire, you might want to revoke. Like, let's say in Argentina, you lose your driver license if you have more than 5 tickets or whatever, right? So there is a mechanism which also allows the issuer to revoke a credential without they knowing where you use your driver license, keeping all the privacy aspects, right?
Okay.
Yeah, and I think one thing that's important to highlight here is that so this thing about I think there are a couple of things. One of them is, I think recovery for like, hey, I lose my device or I lose my devices is the hardest problem to solve here, because if if you assume that you had a bunch of things, unless you can always go back to all of your kind of like issuers and get all of your credentials, you might lose things. So again, you always want to keep kind of like your issuers and make sure they have some data. And also the question is, how do those issuers know who you are, right? How do they know who Jose is? How do they know who Cecil is? So that the reality is that at some point, some mechanism that is not based on presenting a credential and on presenting your private key will be required for these recovery use cases, right? Like if you lose everything, you still exist. So maybe you have to show up in person and they have to take your fingerprints and they have to go to a central database and they give you kind of like a root credential. But there needs to be kind of like a way to bootstrap things. Like, and you might need to go to your university and in person and make sure that like you show up some physical credentials. Whatever that mechanism is, issuance is centralized. There is a database somewhere that has your record. The other thing goes to what Jose was saying about like this private key. So, and this is not necessarily something that you have to do if you're using verifiable credentials, but it's typical, which is the ID property here is it's a URI or URN, and in particular, it is an instance of what's sometimes, and because it's not mandatory, known as a decentralized identifier. And these decentralized identifiers essentially allow you to have a private key and a public key. One sec.
Sure, no problem.
It happens. So decentralized identifiers allow you to have a public key and a private key, in this case, representing like for the user in the phone. And what that means is that, let's say I have my phone or I have a wallet. That wallet will have at least one key for the user that's private, and then there will be a public one in one of these public registries or something like that. And it will be associated to my identifier, so that when I send these presentations here, that's what will be used to verify.
Right. Okay. So one more thing, and then after this, I kind of want to move on and see like how folks can actually start playing around with it a little bit. And then my question is, I've seen a lot of, prior to this coming on online, I've seen a lot of folks talking about like verifiable credentials as decentralized identities. And I've seen diagrams where it looks like, hey, I can have like a multitude of identities, and then they aggregate up into like a main one, right? So if you ask the question like, who is Cecil? Well, Cecil has this identity and that identity and that identity and that identity. And there might be like some level of aggregate, based on, decentralized technology that allows you to do that type of stuff. Is that a thing that your team is looking into also, like an aggregate of the multitude of identities that you might have, or no?
So yes, I think one big caveat there is, when we think about verifiable credentials, we don't imply decentralization. For example, here, right, like this issuer is using a DID method, the centralized identifier method called DID-web. And the way that typically is resolved, or the way essentially you verify that signature, is through common certificates that you kind of like retrieve via HTTPS. So I would say that if you're doing decentralized identity, you're very likely doing verifiable credentials. But if you're doing verifiable credentials, you're not necessarily doing decentralized identity. And that's kind of like not necessarily.
Okay.
In terms of having multiple identities, yes, your wallet software can handle as many private keys as you desire. You could decide to do things like, I have one private key per verifier, and somehow like figure out how to associate them. Again, like this is where it starts to depend on the protocol and the verification rules. But this is functionality that would typically be handled by your wallet. And I expect that if this future becomes kind of like mainstream, or like either verifiable credentials or other specifications for verifiable digital claims are a big thing, wallet apps will become sophisticated and they will handle all of this complexity. Today, we are not looking into the wallet part. We're mainly doing, as Jose will share, issuance and verification. And we are not doing that because we understand that kind of like, again, phones have wallets. Hopefully, Apple and Google will open them up for some of these open standards, and that hasn't happened yet. But that's also something that needs to be figured out in terms of like, what's the wallet that's going to be there for people.
Okay, that makes sense. So Jose, why don't we take a look at, I don't know, like me as a developer, right? I want to at least try it out. I want to play around with it. Like, what are some of the things that I can do, or what are some of the ways I could actually get started trying out verifiable credentials?
Sure, I will share my screen. One second.
Sure.
Okay, sharing now.
All right, your screen's up. So I see the Benefits Club.
Yeah, so I will quickly introduce you to this example, right? This is an example we have built, and I will show you pieces of code and the configuration. Imagine you have, this is like a consumer software as a service or a consumer app where you where the users come to this app, sign up, then buy a subscription, right? They get in exchange some kind of credential they can present at different places like restaurants or whatever, right? And this will give them like a discount or something like that. So this is basically the example. It's an example we have built using Auth0 and Stripe. So I will show you basically some pieces of it. So assume we are getting into this benefit club thing. Sorry about this. 1 second. Okay, we are signing in. This is standard Auth0 authentication, right? And we get this page where we can select a plan, right? So this gives us 50% of discount in restaurants. So we're going to choose this one. This is the Stripe checkout page, right?
Right. Nice.
We are on test mode, and we are going to use the test card. So we subscribe, and so now we have this subscription, and the application knows about it. Let me show you how this works. Like basically, we have a webhook in Stripe. Right here, we are fetching the subscription stuff. We are updating the user metadata in Auth0. This is important. This application doesn't have like an storage, doesn't have a database or anything like that. So we are changing some attributes in the user metadata using the Auth0 API, right? Okay. And now, once the user has a subscription, they can get a credential. This will typically be a QR code or some link, which will allow the user to use whatever wallet they have, right? Because this is an open standard, there would be like competing wallets in the space, and the user might have Google or Apple or whatever. For the purpose of this demo, we are using a wallet we have built and anyone can use. It's wallet.verifiablecredentials.dev. And we are going to request the credential for the benefit clubs, right? And we get the credential here. This credential includes the subject, as Damian showed before, the issuer, the type, etc. So we can choose to, and the proof, right? So we can add this credential to our wallet. Before continuing here, I will show you what this means in Auth0. Okay. It's important to remember this. This is not a feature in the current Auth0 production environment, but you can access and test this feature in auth0lab.com, right? So we have the benefit clubs account, and we have credential issuance here, which is basically some you can specify here some properties about the credential, the branding. This is another standard. This describes how the verifiable credential needs to show in the wallet. What attributes use to show in the wallet, or what are the defaults, etc. Right?
Got it.
And there is another piece, because in this example, you cannot get a credential if you don't subscribe first to Stripe. So there is a piece of Auth0 action here in verifiable credential, which is a code that we run, and it says if the user doesn't have subscription, they cannot get a verifiable credential. And here we specify what we get in the credential subset, as simple as that, right?
Yeah,
you can explore here. Yeah.
A couple of comments there are that the wallet that Jose is showing is a wallet that we built for development and learning purposes. So this is not meant as a production wallet. This is meant as a wallet that makes it hopefully easy for folks that want to learn about verifiable credentials to do so by not having to install anything on their phone, and by being able to explore the contents of the credentials. That we can also show later kind of like how you can even debug what data is presented to a verifier and so on. And the other thing, as you mentioned earlier, Cecil, sorry, is we are using the actions feature, and this is something that was covered kind of like in a previous streaming session. And the way this works is essentially it's a serverless function that you can run at different points in an authentication pipeline. And in this case, we run it before issuing a credential, which allows us to both specify business rules that you should be able to do so. Like in this case, again, hey, if you have no subscription, I don't issue a credential. But also the snippet below shows the properties that the credential will have. So what this means is that you can get any user data that you already have on Auth0 and get that in the credential. But because this is code, you can just make requests to your database or an HTTP request to an API to retrieve any data you need to get into that credential.
Got it. Okay.
Exactly. For this particular example, I decided to store the Stripe subscription when I get the webhook. Another option will be to just call the Stripe API here in the action, right? But we are the important thing is that we are storing here the subscription ID, right? This is the subscription that comes from Stripe. And well, the next step is I am going to try presentation flow. This is something our wallet has, and it goes to this website, which automatically configures for this type of credentials. So you can either scan this QR, for instance, you can run this on your phone and scan your QR. Here you will see in this, this is what we call presentation request, is specifying what type of credential I am expecting. You can also specify here what issuer you accept, right? So we are going to click here, continue, and then we get a prompt in our wallet. 1 second. Says, it's like select your credential to share with verifiable credential, and we are going, because the presentation request has the type, the wallet automatically show here which credential match that type, right? So we are going to present this credential. Boom. Now, if we go to the presentation debugger, we go back to the presentation debugger, we can explore here what the wallet sends to the verifier. This presentation debugger acts as a verifier. And also you can click on these things to explore what they are and what are the public keys, for instance, for this identifier. This is using another website, and you can explore. So as you can see here, this is a verifiable presentation, and inside we have the verifiable credential, which is another GWT. You can also explore what is in the GWT, which should match. Let me see. Should match exactly what we see here, right?
Okay.
Once it loads, the demo gods.
Yeah, I know that goes sometimes.
Yeah. Okay.
Yeah, but while
Trust
that's
me.
going, that makes sense. But I understand what you're saying there. And so now, because it knows the type of credential it's expecting to have, like it shows it. I'm guessing if I had multiple types, I know if that's a use case, but if I have multiple types that match, it would show, and then now I just select the most relevant one to what I'm trying to do.
Yeah, even you can have like multiples of the same type. The wallet will prompt you which one you want to present, right? So, yeah, there are multiple cases like that. Well, the other thing I am going to show you now is what happened when we cancel the subscription, right? We go here, and this is using, I think, a Stripe customer portal or something like that feature.
Yeah.
So we cancel this plan. For the purpose of this demo, I am using like the immediate cancellation of the subscription, right? I am not using like until the billing period ends. So now it's canceled, and what should happen is that I should not be able to use my verifiable credential anymore. So if I go here and I do this, I notice that the status is revoked, right?
Got it.
So how this works? Let me show you what happens if I try to present this. If I tell my my presentation debugger to check revocation, I will try to present a revoke credential. I will get an error. So BC is revoked. The revocation works with this other standard, which is status list 2021. This is currently supported by this feature in Auth0. And the bit of code is similar to the subscription. We have a subscription cancel event where we get the customer from Stripe, the user ID, and then we revoke every credential with the subscription ID from Auth0. This automatically updates the revocation list and make the credential no longer available for presenting, right?
Yeah, one thing there, and this is, I think, like the power of these credentials in one aspect is this revocation list approach. So like if you think about typical revocation for anything, where you are, let's say I have my passport and I have to present it to any verifier, I would expect the verifier to somehow call home, right? It has to call my issuer and say, hey, is this revoked? Otherwise, they have no way to know. If they did that, like that simply, hey, has this passport been revoked? My issuer would know exactly where I presented each of my credentials. So that anonymity aspect that we talked about earlier, where if I have my credential, my issuer doesn't know what I show them, right? That my country does not know what bars I go to, would be lost. So the way it works is rather than checking if one credential is revoked, what the verifier does, it uses the standard to request what's known as a revocation list, which has like 130K entries. And all the verifier does is they download the file and then they check, hey, is this particular credential revoked? But from the issuer's perspective, it's one of those 130K credentials, and it's not clear which user presented the credential to a particular verifier, which helps keep some of this anonymity.
Got it. Okay. So what you're showing us right now, this is in manage.auth0labs.com, right? So for folks that want to try it out, maybe play around with this demo, like where do they go? Like, is there a GitHub repo? Is everything on Manage Auth0 Labs? Like, how do folks get a chance to get their hands on and trying out some of this stuff that y'all have built?
Yeah, great question. So manage.auth0lab.com is what we call the Auth0 Lab environment. That's where the experimental features are. You just go there, you can create an account and you can start working with these. We have 2 tutorials that folks can follow. There's one tutorial to issue credentials, and that tutorial can be found in that URL there, and it's part of the Auth0 Lab documentation. And then there's another tutorial on how you can use Auth0 Lab, but Auth0 to verify credentials. Again, it's very similar to what Jose showed. You create a verifier, you specify a template, and then you write some code to do any additional verification if you want to. Those are the main tools. The other main things we were showing were verifiable credentials.dev, and that's where you can find all the details for what verifiable credentials are. That's where you can also find ID Wallet, which is this development wallet. We did an interop test with a few other wallets like Microsoft Wallet and Ping's Wallet and another company called Spruce, and they had an issuer. Things worked. So again, like you should be able to get things working with other issuers and other wallets, at least if they follow the OpenID for verifiable presentation standard, and if they're issuing with the OIDC for verifiable credential standard. If you have any issues and you're trying it out, let us know, and we can try to figure out how to help. And we also have a Discord, which I actually forgot to share the link. Let me try to quickly find it.
Yeah, sure.
One sec. We have a Discord. This is the Discord for the entire Auth0 Lab team, and all of the past experiments that we've done can be found there in different channels. So we have experiments related to Web3. We have another experiment that we did back in the day related to fine-grained authorization, and it's a new SaaS that we've created, and then this verifiable credentials experiment. So just join the Discord, get into one of the channels there, and again, the team will be there.
Okay, awesome. Well, folks, I mean, I feel like y'all have shown us so much stuff, and I feel like I need a minute to kind of wrap my head around it. But I could completely see the use cases of how this would work, because I can imagine a lot of the times where, hey, I have an online credential, but then I want to use it in the real world as well, right? And so now I can have it on my phone or wherever my wallet happens to be, and now I can present that to people in the real world, and I can also use it in the digital world, which I think for me makes a lot of sense, right? And I think it will make a lot of things much easier. So one last thing I want to ask is, Cecil, could you put the Discord link in the chat? Yes, I will put the Discord link in the chat right now. I did show it on the screen, but I am going to put it in the chat so y'all could go ahead and jump in. Looks like we have some folks that are definitely interested in trying it out. So, okay, there you go. So like the link is in the chat. Yeah, I can definitely see the benefits of bridging those two worlds together for sure. And also just kind of making it a little bit easier for folks to, to walk around with this identity without having to do, I don't know, I could see it being in a world where I don't have to do background checks every time I go to a new job. I could just give folks the same credential. These have already been checked and verified. You can just look at my credentials versus like spending all this time doing background checks and stuff like that.
Yeah, exactly. I think that case, for example, is a very good example where either you have to do the background check again because systems are not integrated. So when you change jobs and change providers, it's a problem.
Yeah.
Or it's a mess, maybe not for the company hiring you, but for the maybe 4 or 5 or 100 companies that are doing background checks, they all have to be integrated with one another. So this goes back to, hey, if your phone is your cache for these credentials, it changes not just the identity parts of the protocol, which it does change a bit, but it also changes kind of like the layout of the system, and it changes kind of like how you think about integrations, how you think about connections.
Yeah, for sure, for sure. Well, folks, again, thank you all so much for coming on, man. We're at about time now. If people want to reach out to you and ask questions or learn a little bit more about yourselves, I'm guessing they could follow you all on Twitter at your handles that are at the bottom, at the top.
Those are our handles, and if folks want to stay up to date with what the Auth0 Lab team is doing in general, twitter.com/Auth0 Lab as well.
Got it. Awesome. And then there's the link for that down below. So folks, definitely make sure you follow the folks at Auth0 Labs. And then definitely feel free to reach out to Jose and Damian about any questions you might have around verifiable credentials. I know me, I'm going to, a little bit later, I'm going to try this out because I want to play around with it a little bit in .NET. I'm a .NET guy. I don't do so much JavaScript. I want to play around with it in .NET and see what it looks like for sure. But with that being said, thank you everyone who's still here with us and are watching. Definitely thank you to our guests. And then we'll see you next week Wednesday, when we usually do Stripe Dev Chats. So thank you again, and we'll see you all later. Bye, everybody.
Thank you, Cecile. Bye.